Chapter 2, Section 7 is about friction. Friction can be our friend or friction can be our foe. Friction is a force that happens whenever two objects are in contact with each other. Friction resists the motion of objects, or in other words, it slows things down. So therefore, friction always works opposite of the motion of the object. It always slows something down. So if something is being pulled in this direction, friction is going to be working in the opposite direction. Here we see why friction works. This is an enlarged version of the picture of these two surfaces together. There are bumps on every surface. Every surface is bumpy. There's no surface that's completely smooth. And so what happens is the bumps end up working against each other and sticking together. The bumpier or rougher the surface, the more friction there is. And it's one thing to talk about friction when something's already moving, but what about when an object is stopped? Why is it harder to get something moving than to keep it moving? There are two types of friction. There's static friction when something is standing still, or dynamic friction when something is moving. And static friction is greater than dynamic friction. So it's harder to get something to start moving because it's stickier. There's more friction there between those two surfaces. Once you get something moving, it's much easier to keep it moving. Again, Newton's first law comes into play here. Something that's in motion wants to stay in motion. Therefore, it is harder to start something moving or to get something moving than to keep it moving. The reason why that is because of something called the coefficient of friction. The coefficient of friction basically is a fancy word or phrase that means the stickiness between the two surfaces. In this example, we can see that an object that has a higher coefficient of friction is not going to move as much. An object with a lower coefficient of friction will move more. But how do we figure out the coefficient of friction? We can use an equation, of course, and in this equation we have the force of friction equals the coefficient of friction multiplied by something called the normal force, or we also call that the support force. Here's an example of a problem including friction. First of all, this object is moving with a constant velocity. And when we have a constant velocity, there's zero acceleration, which means that the forces are balanced. In this case, we have a few different forces taking place. We've got the gravitational force, or the weight of the object, which is 7.35 newtons. We also have the normal force, or the support force, which is 7.35 newtons. We know that those two are equal, and they're acting in opposite directions because the forces are balanced. We also have a force that's pushing the block, and the direction of motion is to the right. The pushing force, or applied force, is to the right with a force of 2 newtons. If the forces are balanced, then we know the force of friction has to also be 2 newtons. Again, the forces are balanced. So any force that is on this side has to be balanced by the force on this side. So one way to determine the amount of force is to simply look at the amount of force acting in the different directions on the object. And if the forces are balanced, we automatically know the amount of the friction. But what if we want more information? We want to know something about the coefficient of friction. In other words, how strong is the friction in the situation? Then we need a little more information. We need to know the force of the pull, which we can get by using the spring scale. This is what we did in the investigation, or what you will do in the investigation when you pull on the shoe. So you find the amount of the applied force, or the force of the pull, in this direction. That's going to be opposite of the frictional force. So remember, if something is moving with a constant velocity, then this force is going to be equal to the applied force. We also need to know something called the normal force or support force, which is equal and opposite to the weight. And the weight, of course, is that force of gravity pulling down. So if you find the force of gravity or the weight pulling down, we know that the support force is equal and opposite to that. And so we can figure out what the normal force is, or the support force, by figuring out the weight of the object. So that gives us the number that goes on the bottom, and the force of friction, of course, is opposite of the applied force. That gives us the number that goes on the top. And when you divide the force of friction by the normal or support force, then you get the coefficient of friction, which is an amount of friction that is for each individual type of surface. So each type of surface has a very unique coefficient of friction, which basically tells you how strong the friction is, how bumpy the surface is. In other words, how sticky the surface is, how strongly will this surface stick to other surfaces. So to figure out the mu, or the coefficient of friction, we can rearrange the equation and get the normal force, or remember the support force, which is the opposite of the weight, divided by the force of friction. That tells us what the coefficient of friction is for different surfaces. So let's go back to this example, and I'd like you to figure out the coefficient of friction for the red box and the green box. Here's the information that you need to know for each box. For the red box, the force of gravity is 15 newtons, and the frictional force is 10 newtons. What is the mu, or coefficient of friction, for the red box? For the green box, the force of gravity is 20 newtons, and the force of friction is 30 newtons. Again, what is the mu, or the coefficient of friction, for the green box? Please complete those two practice problems in your binder in preparation for your assessment on friction. Thanks. Have a great day.